We are. So we're recording right now. So guys, the units, like I said, you've noticed the units are shorter, okay? That last quiz, we had 2 new lessons, review and quiz. So there's not a whole lot of time to get behind in the homework, try to catch up. Good thing is less material, but, only 2 new lessons. This one, there are 3 lessons. Then we review and quiz. We'll be quizzing at the end of next week, okay? So things go shorter in this section, or in this whole semester, okay? So pardon me? Yes, you will need a calculator. So in this unit, we start our study of trigonometry. So this is pre-calc CP. So we did algebra, and now we're doing we did the algebra part. Now we're doing the trig part. That's required of a pre-calculus course, okay? So let's get started. Some of this you've seen before. We're just trying to bring that knowledge back. So trig, one of the ancient branches of mathematics, comes from 2 Greek words, trigon, meaning triangle, and metron, meaning measure, the measure of triangles. That's what trigonometry means. So it's all about angles and measures of triangles, okay? So let's review some things that you should know already. What is a right angle? How do you know an angle is a right angle? It is, right, it has the square, but more importantly and precisely, it is a 90-degree angle, okay? What is an angle that is an acute angle? Right, it's an angle that has a measure less than 90 degrees. And an obtuse angle, yeah, right, so it's more than 90, less than 180. What was that? Why would she put squares in them? If you put a square in it, that should indicate it's a right angle. But she put the square in it? Oh, anyway, I'm not going to trick you on that. I got other ways to trick you. So the sum, guys, the sum of the 3 angles of any triangle on Earth is what? 180 is the number we're going to go with today, okay? Okay. So 180 is the sum of all angles of a triangle. A right triangle has how many acute angles? 2, okay? If you think about a right triangle, so we've got one drawn right below here. If you've got the right angle, that's 90 degrees. The other 2 have to add up to what? They have to add to 90, so they're less than 90. So there are 2 acute angles. The sum of those acute angles is 90 degrees, okay? Now, in right triangles, we also label the sides. There's certain nomenclature that goes with that. The side that's opposite the right angle is always called the what? Hypotenuse, okay? And then the other 2 sides we refer to as what? Well, we will get to that, but they're just called legs of the triangle, okay? So the triangle has 2 legs and 1 hypotenuse, the right triangle, okay? If you ever see something on a test that's asking you to solve for this, this is not the way to do it. You don't just came off of something on the internet. You don't just circle and say, there's x. How would you find the value of x? What would you use? Pythagorean theorem is what you would use. That always goes with right triangles. So that's something that you should know. We'll bring that back right here in a hurry. So from the Greek mathematician Pythagoras, gave us the Pythagorean theorem. So what it says is, the sum of the squares of the 2 legs of the triangle is equal to the square of the hypotenuse. So if this is, one leg is A, one leg is B, and that's a 90-degree angle, then A squared plus B squared equals C squared. You've seen that before, right? This is whenever all the kids are nodding. I'll record that in the video here. So, oh, it's just right here on audio. It's just you verbally. So, okay, now we're also going to use terms, guys. We're going to use terms to refer to sides of the angle: opposite, adjacent, and hypotenuse. Okay, this is so based on where we are on the triangle, sort of to navigate which sides we're talking about. So for example, look at the diagram you see here where you've got this angle, and we'll use Greek letters a lot in homage to Pythagoras. This is just the Greek letter theta. I mean, it could be angle A. There's nothing special about it. So it's just a Greek letter theta. So if I look at this angle, if this is where I'm sitting, this is always the hypotenuse, the one opposite the right angle. You know, which side is opposite this angle? Maybe the one that's labeled opposite, okay? What side is adjacent to this angle? The one that's labeled adjacent. See, you guys are on top of this. Now, what if you saw something like this? This is angle beta. Which side is opposite angle beta? How about the one down here that's on the bottom? That is the opposite side. Yeah. What is this side right here? This one. That's always the hypotenuse. And then what is this side here relative to this angle? It's the what? It's the adjacent, okay? So the hypotenuse never changes, okay? But based on which angle you are at, the opposite and the adjacent do. So if this is where I'm at theta, the opposite is up here and the adjacent is here. If I'm at angle beta, this is opposite, this is adjacent, okay? So that's terminology you've used before. We'll continue to use throughout this. And this is what you should circle, highlight, star, everything. This is one of the bases of everything this unit are these definitions of trig functions, okay? But you guys can handle it. We're going to pretend like, we'll pretend like you're seniors and you're getting ready to go to college. So this will help us, okay? So there are only 6 functions, okay? 3 of them you've seen before, 3 of them you haven't. So you should have seen sine, cosine, and tangent in a past life. So the sine is just the value or the ratio of the opposite over the hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now, the functions that you see here below are called reciprocal functions. Does anyone know why we call them reciprocal functions? Well, what's the relationship between this and this? Not opposite. What word would you use for that? Reciprocal, okay? So the cosecant is just the reciprocal of the sine. The secant is the reciprocal of the cosine. The cotangent is the reciprocal of the tangent, okay? So these functions, the 3 at the top you know, the 3 below are new, but it's just reciprocal functions, okay? Now, there's an acronym. I don't know how you learned it when you did this in geometry. There's an acronym. It was on the video that you saw a moment ago. SOHCAHTOA, S-O-H-C-A-H-T-O-A. What this means, and this can help you, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So that's an acronym. There are other acronyms out there on the internet. I hesitate to tell this class, but you get some rated G-rated, and there's some different ones out there as well, but not right now. Come on, Carter. So, there are other. Pardon me? No. Oh yeah, I do. Yeah. Okay. Yeah, we won't get into that right now. So, so guys, SOHCAHTOA. If you can remember that acronym, SOHCAHTOA. Okay. If you can write that down on a piece of paper when you start your test, this will tell you that the sine is just the opposite over hypotenuse. The next one, the cosine. The cosine is the adjacent over hypotenuse. The tangent is the opposite over adjacent. So you've got to know this, okay? Some people find it helpful just to write it down, and that way then you've got it to refer to on the quiz. Now, the reciprocal functions, guys. Tangent goes with cotangent. In each of these pairing, there's one function that starts with a co, and then one that does not, okay? So tangent, cotangent, cosine, secant, sine, cosecant. Each of these pairings, one of the functions starts with the letter CO. So sine goes with cosecant. Cosine goes with secant, tangent goes with cotangent. So the cotangent is just the reciprocal So what's the reciprocal of opposite over adjacent? Yeah. So adjacent over opposite. So I don't really memorize these guys. If I memorize the top three, yes. Okay. If I memorize the top three and then know, okay, what's the one that goes with cosine? It's what? It's secant. So it's hypotenuse over adjacent. Okay, let's keep moving on. Sine, what's the reciprocal with sine? It's just cosecant, and that's going to be what? Hypotenuse over opposite, okay? Okay, guys, I need you all up here, okay? So there are only 3 days of this lesson. You're going to have to know these 6 functions, okay? Like I said, pardon me? No. So you've got to figure this out. So this is why I'm giving you a mnemonic. This is how you remember sine, cosine, and tangent. Then once you know that cotangent is the reciprocal of tangent. Secant is the reciprocal of cosine. Cosecant is the reciprocal of sine. So if you can memorize these 3, these are just the reciprocals, okay? So you're going to have to know this. Everything on the rest of the unit is based on these 6 functions. So another way of thinking of it is just the sine. If you look at it, the sine is just the reciprocal. So if this is sine, cosecant is a reciprocal. If this is cosine, the secant is just the reciprocal of the cosine. Tangent, then cotangent is the reciprocal of the tangent. So you can write it as 1 over the tangent, or it's just adjacent over opposite. Okay, so these are not inverse functions, they're reciprocal functions. All you do is by form is by reciprocating or flipping the fraction. Okay, now let's do a few examples using this. So let's look at this right triangle that I have drawn, and let's figure out the value of all the 6 trig functions based on this triangle. Okay, so how many sides of the triangle do I know? I know 2. How can I figure out the third one? Yeah, Pythagorean theorem. Okay, so if this side is x, and that's what I'm trying to figure out, I know that x squared is equal to what? Which is, yeah, so 7 squared plus 2 squared. So x squared is equal to 49 plus 4, which is what? 53. So x squared equals 53. What does x equal? What is it? Square root of 53. Okay. There are no decimals. There are no approximations. That is the exact answer. That side is the square root of 53. Now, what's the definition of the sine function? Opposite over hypotenuse. So, if I want to figure out the sine of this angle, so the sine of this angle is, what's the opposite? What's opposite is 7. 7 over the square root of 53. That's the sine of this angle, okay? The cosecant is the what function relative to sine? It's the what? Reciprocal. So the cosecant is the hypotenuse over opposite. So what is the cosecant of this angle? Yeah, it's just the square root of 53 divided by 7. What's the definition of cosine? It's the what? It's adjacent over hypotenuse. So what's the value of the cosine of theta is what?
2.
Right? Divided by 2 divided by the square root of 53. Okay? The secant is the reciprocal of the cosine. What's the value of the secant of theta? Yeah, square root of 53 over 2. What's the definition of the tangent? It's the opposite over the adjacent. So the tangent of theta What's the value of the tangent? What do you mean? You're what? You're on the wrong problem? Okay. Well, we're on this one. Come on, guys. What's it? You got it. 7 over 2. I guess I was interrupted by Jake. What's the cotangent of theta? 2 over 7. See, Bella's with it back there, guys. Okay. So, again, all you had to know was the definitions, sine, cosine, tangent. Once I know the tangent, the cotangent is just the reciprocal. Once I know the cosine, the secant is just its reciprocal. If I know the sine, the cosecant, it's simply the reciprocal. Okay? So fairly straightforward. Now we'll move on to one that Jake was ahead of us on. Consider this right triangle. Find the exact value of all 6 trig functions for angle theta. Okay? How do I find the hypotenuse? Yeah, so x squared is going to be what?
X squared is 3 squared.
3 squared plus 3 squared, which is 9 plus 9. Yeah, so x squared equal 18. Okay, what does x equal? Square root of 18. So this side is the square root of 18. Okay, I'm okay with it being the square root of 18. What some people will do is the square root of 18, that's the same as the square root of 2 times 9. What's the square root of 9? Yeah, so this is 3 times the square root of 2. So either way here. Yes. Okay. So, what is our definition of sine, guys? Yeah, opposite over hypotenuse. So if you look at this angle right here, what's the value of the opposite side? Yeah, so this is going to be the sine of theta is 3 divided by what? Yeah, 3 over square root of 18. Okay. Cosine, what's the definition of cosine?
1 over sine.
No, cosine. Cosine is adjacent over hypotenuse. I'm just writing these down. Over time, you'll get to where you know this, but I'm just writing it down. So the cosine of theta is adjacent. So which side is adjacent? This one. So it's 3 over square root of 18. The cosecant is the reciprocal of the sine. So what's the cosecant? Square root of 18 over 3. The secant is the reciprocal of the cosine. So the secant of theta is square root of 18 over 3. What's the definition of tangent? Yeah, opposite over adjacent. So the tangent of theta is what? 3 over 3, which is 1. What's the cotangent? 1. Okay, so the cotangent of theta will also be 1. Okay. So again, I mean, one of the key things here is you've got to know sine, cosine, and tangent. You know, so whether or not you remember it with the acronym of SOHCAHTOA or some other thing, find some way to memorize what these 3 functions are. Once you know them, sine pairs with cosecant as its reciprocal, cosine with secant, tangent with cotangent, and those reciprocal functions are just what the name says, reciprocals. So you flip the values. Okay? So let's do a slightly different twist on this problem. So let theta be the acute angle of a right triangle such that the cotangent of theta is 5/3. Find the exact values below without a calculator. Okay. Now, one skill you're going to need throughout, I keep saying one skill, but one of many, is you need to be able to draw diagrams, okay? So in this one, it's telling me about a triangle, so I'm going to draw this triangle. And there we go. Well, it's a right triangle, so I know it's a right triangle, Okay, they're asking me about some angle theta. It doesn't matter which one. I could call it this angle or I could call it this one. Doesn't matter. You have a preference. The top. So we'll call this angle theta right here. Okay. What do they tell me in this problem that I know about the angle? Is the what? Cotangent. So what's the definition of tangent? Tangent is opposite over adjacent. Therefore, what's the definition of cotangent? Adjacent over opposite. Okay. So if I know that the cotangent of this angle is 5/3, that means that 5 is the length of which side? Adjacent, and 3 is the length of the opposite. So if this is angle theta, which one is 5? Yeah, that's 5, and this one is 3. Okay? So this is where the previous problem started. I gave you the triangle and I gave you the numbers. Now I backed it up one step and gave you the value of one trig function. You had to draw the triangle to figure that out. Now, how do I find the hypotenuse? Right, so if I want to figure out what this is, so x squared is going to be equal to 5 squared plus 3 squared, which is what, 25 plus 9. So x squared is equal to 34. So what is x? Square root of 34. So the length of this side is the square root of 34. So if I look at this angle, what's the definition of sine? Yeah. So what is the sine of that angle? Yeah, 3 over the square root of 34. Okay. Let me move over to cosine. What's the definition of cosine? Adjacent over hypotenuse. So the cosine of this angle is what? Yeah, 5 over root 34. Okay. The secant is the reciprocal of what? Cosine. So if this is the cosine, what's the secant? Well, there's an easier way of doing it. Just you flip it. No. It's the reciprocal of this. Okay. The reciprocal of that is just switch the numerator and the denominator. Okay. If I had, so like this, the reciprocal of 1 over this, when you have a fraction in the bottom, you just flip it. Okay. That's what this is. Okay. So yeah, the reciprocal is 1 over this, but it's just switching the numerator and the denominator. Okay. So we've got a couple more here before we're done. Let alpha, I'm just using different Greek letters of the alphabet. Let alpha be the acute angle of a right triangle such that the tangent of alpha is 12/5. Find the values of the other trig functions. So draw a triangle, which is a key theme for many of these. Okay. Which one of these do you want to be angle alpha? Okay. You can label the top one or the side one. It does not matter. So that's angle alpha. What do I know about angle alpha? The tangent is what? Yeah, so the tangent of alpha is 12/5. What's the definition of tangent? Opposite over adjacent. So if I look at angle alpha, how long is the opposite side? Yeah, the opposite is 12, and the adjacent is 5. Okay, and then how do I find the hypotenuse? Yeah, so x squared is going to equal 5 squared plus 12 squared. So x squared is equal to 25 plus 144. X squared equal 169. What is the square root of 169? 13. Okay. Yeah, so this one, x is 13. So, what's the definition of sine? Yeah, opposite over hypotenuse. So what is the sine of alpha? Yeah, so it is 12 over 13. The cosecant is the reciprocal of sine. So what's the cosecant? Yeah, 13 over 12. The definition of cosine. Cosine is what? Adjacent over hypotenuse. What's the value of the cosine here? 5 over 13. The secant is the reciprocal. So what's the value of the secant? Yeah, 13 over 5. We know the tangent is 12/5. What's the cotangent? 5/12. Okay. Okay, pretty straightforward, but you just need to be solid in the six functions. 3 of them you need to know, and the other 3 are reciprocals, and that will help you. Let's do one more here before we're done. So you should have some space, I think, in your book to do this next one. Here I give you this particular triangle, and we want to solve for all the trig functions. Okay. The side that I don't know here, is that a hypotenuse or one of the legs of the triangle? It's one of the legs. So how do I use the Pythagorean theorem here? Yeah, so 7 squared is equal to what? Well, I know that, but well, in this context, yeah, so well, x squared plus 5 squared, okay? X squared plus 5 squared equals 7 squared. In this triangle, here's x, here's 5. So the Pythagorean theorem here is 7 squared, the hypotenuse, is equal to the sum of the squares of the two legs. So 49 is equal to x squared plus 25. If I subtract 25 from both sides, I get 34 is equal to x squared. So x is equal to, 24, sorry. Yeah. So x is equal to what? The square root of 24. So this side is the square root of 24. So if I look at this angle, what's the definition of sine? Yeah, sine is opposite over hypotenuse. So what's the value of the sine of that angle? Over 5 over 7, okay? The cosecant is the reciprocal of the sine. What's the cosecant? Yeah, 7 over 5. The cosine is adjacent over the hypotenuse. What's the value of the cosine? Yeah, square root of 24 over 7. The secant is the reciprocal of the cosine. So what's the value of the secant? Yeah, 7 over square root of 24. Tangent is, what's the definition of tangent? Yep, opposite over adjacent. So what's the value of the tangent? Yep, 5 over square root of 24. Cotangent is the reciprocal of the tangent. So what's the value of the cotangent? Okay. And there we go. So, to review, I mean, the big thing, guys, you really need to get a handle on right away is the value of these six trig functions. What are their definitions? You've got a mnemonic that can help you with 3 of them, and then the other 3 are just reciprocals. So understand that these are the reciprocal functions, And the things we did today, if I give you a right triangle with two sides, use the Pythagorean theorem to solve for the other side. Once you know all of the sides, then you can come up with all the values of all the trig functions for that right triangle. Yes? Yeah. Give me just a second then, okay? Alrighty, I'll go ahead and turn this off.